Here we have a centroid problem where we're looking at a composite object, right? We have a line that has 1, 2, 3, 4 parts. So maybe we'll just start naming those. So this is our line 1, this would be our line 2, 3, and 4. So we have those lines, we'll have our, we'll do those later. Let's start with our table, right? If we're looking for our centroid for composite object, then we have to create our table. So let's see if we can squeeze that table in here somehow. So we have I, we have Li in millimeters. We'll need X bar I, also in millimeters. We'll need Y I bar in millimeters. We'll need xi bar times Li millimeters squared, and then yi bar times Li millimeters squared. All right. So we have that, and then we have 1, 2, 3, 4 segments. So 1, 2, 3, 4, and then the sums. 2, 3, 4. And then let's see what we can add into this table here. I think it's just about to fit. All right, we already know these two we don't need, but the rest we'll need to fill out. So we'll go with lengths. Now, what is the length of segment 1? Well, it's at an angle, so we'll just do Pythagorean theorem, right? So we know in the x direction, we are from -2 to 6, so that would be 8 in one direction. So we can do a square root of 8 squared, right, from -2 to 6. And the y direction goes from 0 to 6, so that would be 6 plus 6 squared. And that is 36 plus 64 is 100, so that would be 10. For the second one, we have another one at an angle, so we can do the square root. Now this in the x direction is 1, 2, 3, right, from 3 to 6. And then from 2, let's write that in here. We said 1, 2, 3, almost wrote 6. 3 squared. And then from 2 to 6, so plus 4. Another nice one. Oh, we know, of course, that is 9 plus 16 is 25, so that would be 5. Now the third one, that's a little easier because that's nice and straight. So it goes from 2 to -2, so that would be 4. And then for this one, it goes from 3 to 0, so that would be 3. All right, so we have 10, 15, 19, 22 is the total length of our line. Now we need to look at our centroids, right? We know the centroids are going to be halfway along here. So it'd be half in the x direction and half in the y direction. We said the x direction was 8, so it'd be 4. -2 plus 2 should be here. Right, that would be the centroid. So let's see if it works in the y direction, right? We said it was 6 high, half is 3. That looks good. So we can write that down, right? We know that in the x direction we get 2. And in the y direction we got 3. Then on my second one, right, I said 1, 2, 3, so at 1/2. So that would be 4.5, so somewhere around there. And then in the y direction I have 4, so I'm going 2, so it'd be 4. All right, sounds good. So in the x direction we said we have 4.5, right, just looking at our graph here. And the y direction we are at 4. And then for the other two, it's a little easier because they're just straight up. All right, so if I know my center, it has to be here because it's halfway in between these 2 points from -2 to 2. That means in the x direction, 1, 2, 3 is the coordinate, and in the y direction is 0. And then for this one, centroid should be here, which is the middle. So that's half of 3 in the x direction, so that'd be 1.5. And then I have to go -2 in the y direction. -2. All right, and with that, we've done all the intellectual heavy lifting. Now it's just calculations, right? If this were in Excel, then we'd basically be done by now. So we say xi times li, so that'd be 2 times 10 is 20. Then we have xi 4.5 times 5. And that is 22.5. Then we get 3 times 4. 3 times 4. Oops, not 40. Is equal to 12. And then we get 1.5 times 3. And that is 4.5. So that's 20, 42.5. 42.5 plus 4.5 is 46. 47 plus 12 is 59. And then the same in the y direction. So yi, so it'd be 3 times 10 equal to 30. Then we get 4 times 5 equal to 20. Then we get 0 times 4. That's, of course, just 0. And then we get -2 times 6. Times 3. Already have the calculation, so -6. Very important, that's minus. So we have 50 minus 4 would be 44. Excellent. And with that, we can find where our centroid is, right? Because we can say x bar is the sum of I equal 1 to 4 of x bar I times Li divided by I equal 1 to 4 over of Li. And so that'd be 59 millimeters squared divided by 22 millimeter, right? My Li and my x times Li. And if I plug that in, I get 2.68 millimeters. That x bar is my x bar, and then my y bar is going to be sum of I equal 1 through 4 of yi bar times Li divided by sum of I equal 1 to, oops, not left space, 4 times Li. And so that's then 44 millimeters squared divided by 22 millimeters. For that, we don't even need a calculator. That's just 2 millimeters. All right, let's see then. So in the y direction, it's 2 millimeters, and the x direction, 2.6. 2.5 and 2 be here, so somewhere around there, right? That'd be C 2.68 comma 2 millimeters. All right, very cool. So with our tabular method, we were pretty quick to find where the centroid is for this composite line.